Hello and welcome to yet another video on how we're going to constructing given isometric figure accurately showing all construction details. Subscribe and like. So we have a reference line. That's step number one. We're drawing a reference line, and we are also drawing the starting point because this is isometric projection. The lines are inclined at 30 degrees while the vertical will be at 90 degrees. So right now we are looking at the different measurements that were given to us, and we are marking them off along the reference lines, just like you're seeing. 60 on the right hand side, 100 millimeters on the left hand side, and then the total height when you measure looking at the distance was given. We have 40, we have 20, and this adds up to 60 millimeters. So you have a total height of 60. On the right, you have a distance of 60, and on the left, you have a distance of 100 millimeters. What I'm doing right now is that I'm constructing a cuboid, which which is equal to the total distances across the whole box. So that's what we're doing right there. Yes, if the video is a bit fast, you can pause and also follow, because this is a step-by-step process meant to help you draw set figures that might seem complicated at the beginning. But with this video, you should be able to go through step by step to come up with it there. I am using a T-square, which I slide against the drawing board, and so it's easy to draw, horizontal lines. So I'm just using the T-square and 6-degree square to do all this. It's just a matter of sliding all the time. So right now, as you might see, I have obtained the L shape. Uh, just using the distances. I marked off 20 and kept on drawing. All these lines are supposed to be parallel to each other. So when you have the reference lines, the rest of the lines are parallel. What I'm doing at that point, though, we're now getting the center point. Those two lines, that line and the vertical that you see represents the center lines of the curves that we see. I hope you see that our curves, we have a curve of radius 10 and a curve of radius 25. So right now I am going to start by constructing a curve of radius 10. How that is done, we draw a square. We first of all draw a square in isometric having radius 10, and so using my compass, I mark off the distance of 10 millimeters and mark it off on the inner side of those axis lines that I have drawn in there. So you have 10, 10, 10, 10, and thereafter I'm going to construct a square. And that's how we construct our square. Yes, I hope you're following. This video is meant to be short and engaging, so in a very short time you should be able to come up with this complicated diagram. And it's not exactly complicated, you will realize after you have finished. So the principles of drawing circles in isometric, I shared them in the video earlier. We're using the compass method, where we draw lines from the shorter diagonal to meet the opposite side, and then we have that line from the longer diagonal which you would have drawn to the meeting point. In case someone is lost, you can join my earlier video which introduced us to this method, the compass method of drawing isometric circles. That's the method I'm using right now. Right now we just don't want to make the work very untidy, and so we make the work as faint as possible so that we don't have too many lines involved to make the work untidy. But yes, we have now drawn, as you can see, the center for that is the one of the shorter diagonal of that square, to draw the arc which joins there, like that. So that we have obtained that first circle. While in the question, we are able to see the thickness. When you try to draw the thickness in this particular, in the actual thing, it might not work out. So I left it at that, and I then proceeded to the next um, the next part. The next part is that half, that semicircle that we're drawing in isometric, and again we have to get the square, which equals to the diameter, and the diameter in this case is 50 millimeters. So I have drawn the square, diameter 50, and I'm drawing the longer diagonal. And in this case, because it's half of the because it's half of the of the of the circle, it's only the upper part where we draw the line that connects to the diagonal. So using that part, we shall draw that curve, just like you see in the diagram. It's not very difficult. And then that's the first one. Then the next one, we shall use that other inner point as the center to draw the next curve. Yes. So that's how we obtain that curve. We now want to see how we get the thickness. We want to get the lower curve. There are several ways we can do this, but in this case, I decided to still use the compass method. Like what I did was transfer the center from the upper circle to the lower circle. So I I first of all got the center, measured the height. I measured the height there, the height of 20, marked it down to this lower part, and stretched my compass using the radius of the upper circle, which we already obtained, and I was able to draw the curve which connects the lower part. And then for the inner part, there is that small part which we also have to account for. We draw some random lines and mark off the given height, and we can join that small part using freehand. So it's a combination using compass and freehand. And finally, we are left with the final thing, and that's outlining. We have drawn the circles. The circles need some bit of dynamics, and we have gone through those. So after that, we just have to outline the final figure uh, to show us how exactly our answer will look like. So what I'm doing at this point is outlining so that we're able to see how our final figure looks like. Yes, I want to thank you very much for your kind attention. Continue to like and subscribe. We are here to do this kind of work for you. Thank you.